reality.
Yeah, hence the humble word theory. It's just the best one we got is the one at the top.
But we know it doesn't work. Dude, the beef I have with relativity is that what happened was that we had some tests that didn't match what we thought it would do. And to get out of it, right, relativity made up a paradigm basically that said, okay, look, it looks like this is the test results, but actually that's an illusion. And actually it did exactly what we would predict, except we can't tell from within the illusion. And time slowed down and the measuring apparatus got shorter but looks like it's the same length, so you could never really be able to tell. That's a wild claim, bro. So like, it's unfalsifiable.
Do you have any specific? That sounded like a specific study or something you're referring to there.
Yeah, the Michelson-Morley experiment. And
Yeah, classic.
yeah, I mean, and Einstein explains this in Special and General Theory, where he talks about Michelson-Morley, and I mean, he talks about it so extensively because he's also quoted as saying that he came across the peculiar results of Michelson-Morley, and that's what led him down the path to special relativity. Which is proposed as a solution to the problem that they did not detect Earth's orbit. And he says that the distance contracted just the exact sufficient amount needed to make it look like the Earth was not moving. But it's going to look like it's the same. Like it's going to look like it didn't get shorter because you're on the Earth, so you won't be able to tell.
The specifics of that exact thing. I do know we can prove time dilation in a lab, though.
How so?
Measuring decay.
Proof?
Yeah, we do it with muons. Yeah, I mean, if you want. The way it works is pretty simple. If they are moving near light speed through acceleration, then you would expect them to decay in a way different rate when you measure it afterwards. And we do measure, this is how we measure time dilation, because they're so light, they're very, very easy to accelerate. But I can find some specific studies if you want proof. Yeah, you could follow the methodology if you have the equipment. But
I could give you a little example, like geosynchronous satellites. They claim that they have to adjust the clocks because of time dilation, their distance from Earth. That's one they usually bring up.
Yeah, I think we ran down that many times in here, and people usually misunderstand the frequency alignment of what when they fine tune for the frequencies, right?
What do we misunderstand about it?
I don't know the full. They always bring something about frequencies up, which I'm not entirely sure of what it is.
Right. So if you don't know what it is, how would you know that we misunderstand it, bro?
No, this was a very specific topic. I don't remember the specifics, but after looking it up, I remember it making complete sense. We talked about it, and I think we're all in pretty much. No, it sounds stupid. I don't remember exactly. There was some oscillations, and I think the
they use a
misinterpretation was
microwave
a band of.
I'll tell you what it is, right? They use a microwave resonator to tune the cesium atom to have the correct oscillation rate, and they count a second with like 9 million oscillations or clicks, 9,127,000, whatever it is, and that's equal to 1 second. And so as the device runs, they begin to fall out of alignment of that rate. So they tune it with a microwave resonator and they change the frequencies as needed to keep it within that oscillation rate. So they're cooking the books. They keep
Yes.
it within that rate, and then they claim to observe an effect after that that's claimed to be consistent with relativity, it's time dilation, but that isn't true either, right? Like even if you go to the original test, Just a second. The original most famous test, they claimed to use atomic clocks on planes and that it showed that time dilation was real. The idea being that if the plane goes in a certain direction at a higher altitude, that time goes slower. But what the test actually showed, if you actually look at the data sheets of that test, is that the quote unquote time slowed down. It increased and decreased both east and west. So it showed that it went all over the place in both directions. It didn't match at all. And you fast forward to now where
Wait,
they're like cooking the books with the microwave resonator. So
Makes
It
sense.
increased.
yeah, I understand. Yeah, no, it should be the same in both directions, should not? And why does that? I mean, even if it's the same in both directions, why would that? Why would you not expect to have to tune it the same way? I do
think,
remember
think,
more of the argument now.
think about this logically, okay? Time dilation is basically saying that time is physical and it stretches out and it causes it to slow down. That in and of itself is just absolutely insane and makes no sense, but let's just pretend it makes sense for a second. Normally, what people do is they pretend it does make sense to them, even though they know it doesn't. But like, because Einstein admitted it doesn't make sense to him. But whatever. Let's pretend it makes sense that time stretches out and slows down. Okay. If it slows down based on the speed of the satellite or the plane, right? Then why was the data showing that it both increased and decreased? If the time is slowing down, then the time shouldn't be increasing and decreasing. Should be only increasing
Yeah,
or actually decreasing.
I'm just asking about their microwave thing because I didn't know that, so that was really cool. What? Why would anyone assume that the microwave is being supplied by power, right? And the power is from the national grid, right? So if that power there fluctuated, then surely the microwaves that they are using would be fluctuating as well, right?
Unless they had some sort of battery, perhaps.
If they use, yeah,
yeah,
yeah.
I agree. Like it's calibrated for that value at the Navy base, right? So it only makes sense that if you move it, change it from its original calibration settings, you take it out of that environment. It does, to me, make sense that it would no longer remain in alignment. Personally.
Yeah, so would anyone know that we keep time by battery, or do we keep by the national grid? And if it's by the national grid, you've got like, I'm going to say at least 1% discrepancy, but I think there's about 5% leeway. But even if you said just 1%, you're still going to get a variation, surely.
Yeah, are you saying it literally could decrease in time comparatively when moving?
If your power supply is altered and is very, it varies, then whatever you're doing is going to vary as well. You would need to have a battery pack with 2 wires. That's it. And then, then I guess all sorts of things could be happening to try and create these microwaves. But do we have battery packs that can create microwaves? I guess so, but maybe not.
And now we're talking about the adjustment, right?
Well, I mean, if anyone's mentioned a battery pack, how are you going to power the battery pack? It's not going to be forever, is it? So you need a more of a unlimited source in a way.
Well, depends on how long you're going to run this thing, right?
Well, yeah, you're going to run it forever, aren't you? So while the national grid's run, you can keep this
But
time ticking.
I just want to get this clear. Witsit, you're saying the experiment showed both an increase and decrease in relative time,
Yes. In both cardinal
and that was
directions.
never revised? Because that should not happen in time dilation. If it speeds
I
up
know.
relative to you,
I agree.
so
Yeah. This is what's so weird about it, right? Is if like you Google it and ask like what proof do we have that relativity's time dilation is true? Like the initial proof invoked is Halfing and Keating, and they'll say the story about how they put atomic clocks on a plane and they flew the plane, and based on the relativistic prediction, the clocks matched what relativity predicted with time dilation, and time slowed down based on the speed of the plane. And this was the first verification of time dilation. That's what like all the mainstream sources will tell you. That's what you'll hear tons of people repeat. We actually went and tracked down the original documentation from them themselves and their actual recorded data, their own charts. And what it actually showed in the data was that it increased and decreased in both directions. It was super inconsistent and it went in both directions, in both cardinal directions. So why are they lying about it? Why does like the mainstream story about that test that it matched the prediction when you can literally just go look at their own data and it shows it didn't? So I
Right,
mean,
yeah.
good
I
question.
haven't seen
And
this.
this
I know nothing about that, but
we had the same experience with the 1919 Arthur Eddington experiment, which was supposedly one of the first verifications of relativity, which is where they saw a star from behind the eclipse, right? A gravitational lensing. And then when you actually go look into it, you find out that there were like 34 photographic plates they were using to make the observation, and 31 of them did not record the observation that relativity predicted. It's claimed that 3 of them did, but conveniently those 3 were damaged, so couldn't ever be independently verified, weren't preserved. And then we found Eddington himself actually discussing it, like writing about that test, saying that it was a major problem for relativity. The results were a major problem for relativity. But again, if you Google it, it will literally tell you that the Arthur Eddington experiment of 1919 verified relativity. So we're
Yeah, that's
seeing
what
a theme
that's what
right.
here.
I've always
This is
heard.
one. Just real quick, you can prove it geometrically. Are any of the geometric proofs for time dilation sufficient to you? Do you know about the? Can I mention a quick one to see if everybody's on board with this? If you have a light beam bouncing up and down between 2 plates, like just geometrically figuring, let's say that bounce from up and down takes time x, so it could be any time, right? Any distance. If you start moving along with that light thing moving up and down, where it's moving relative to the plates next to it, it will go up and down in the same exact amount of time because up and down is unaffected, but it will form a triangle shape, meaning it has to take 2 hypotenuses instead of a height of a triangle to reach up and down, and it will have taken the same time. And this is why in relativity, c always has the same speed. And because it does, when you move relative to something else, you will necessarily having experienced a different time frame.
What? How does this prove time
Just
slows
what?
down?
Well, I mean, if the light has to bounce in a triangle, are you not agreeing that it's a longer path, but it still takes the same amount of time to go up and down?
It doesn't.
It definitely does. It has to travel that diagonal 2 times. The speed of light would have to increase to be able to make that up and down in the same amount of time, which it doesn't. That's why relativity claims c is the same for all observers, thus geometric time dilation.
If light is constant and it's going 2 different distances, then it's going to take the light longer to go the longer distance if the speed of light's actually constant.
Right. So it's a
Right.
longer path being taken, and the speed doesn't increase. The speed doesn't increase, so the light is actually going to take a different path that would have taken a different amount of time compared to just vertical motion. And you can
But
also explain
the
time
time does
dilation.
increase.
It's only relative to what the other observer experienced in the geometry of space-time.
They're all within the same
There is
reference
no
frame.
absolute. If it's in the same reference frame and nothing is moving relative to something else at any different velocity, then you're gonna experience the same time. Yeah.
Okay, so this is the problem. When they went to use interferometry, which is light interfering with itself, they shot a light beam, they split it with a beam splitter to ensure that both of the light beams were perfectly in phase because they were originally the same light beam. So if you try to shoot two light beams at the exact same moment, you could never get it perfect. So they just split a light beam to ensure that both of the light beams were perfectly in phase with each other. Then they splits and goes in perpendicular to each other, hits silver mirrors and bounces back to meet each other back in the middle, and then recombines and goes back to the receiver. And they start to intersect and overlap, right? Which is the interference, the phase shift, the fringe shift, because one's slightly behind the other. Because if the Earth were moving, then one light beam is going to travel a different distance than the other based on which direction it was going. Right. And then if you know how
This is the
fast the Earth is moving, if you know how fast the Earth is moving, then you know what that separation between the two light beams are going to be. It's a really simple equation. You the velocity of light, the velocity of the Earth's orbit, right? And you understand that there's a greater distance, that's a greater time. So there's going to be a specific separation based on the distance of the apparatus.
Can I
They did not.
interject because I
They did.
think that's wrong.
Which part's wrong?
What you were saying there. This is the important part about relativity and different relative frames, right? Of perspective. Like you're saying, we know the speed that the Earth must have moved due to a shift in the or the orbit around the sun. And what about the galaxy and the galaxy clusters? Like, at what point do you stop making these speed comparisons, and how can you determine which? Because on Earth, if they're standing on the same surface, they should be like zero. It doesn't matter at that point. It's the
I was
same
trying to teach
reference.
you what happened. Like you just interrupted with some random irrelevant comment.
No, I'm sorry. I thought there was a disagreement about.
It's all good. I mean,
Um,
the part about the galaxies and stuff is actually an interesting point because at the time they didn't even know about that. So at the time they didn't know that the model was going to develop to claim that the sun itself was going through the galaxy at 500,000 miles per hour and that the galaxy is going at 1.2 million miles per hour. And I've seen a lecture from, I believe it was a Stanford professor explaining that, you know, they didn't even account for that, but it actually would have varied the friend shift significantly. But anyway,
Really?
they didn't even know
Galaxies
about
haven't
that at the
been.
time.
I didn't know that Witsit, that galaxies, other galaxies and stuff, and the way things worked hadn't been discovered when they did that. I didn't know that.
Yeah. Yeah, they didn't know. Yeah, yeah. So those speeds weren't even thought of, right, in 1887. But conveniently, right, for the current model, it doesn't matter now, right, because we're in the Earth's reference
This
frame.
GR
So
shit's
no,
bullshit, dude. It's out the window. It's out the
so
window. They just made a Mon prediction about a rotating galaxy, and they made a GR dark matter prediction with the same galaxy, and the rotation matched Mon much better. Like GR is done, dude. It's a fairy tale. Like the only reason they were able to sell it is because Michelson Morley was like, "Holy shit, we're not detecting the orbit. You know what I'm saying? How do we make it go in a straight line? Like this all his whole thing's ad hoc. All
so
GR, Lorenz contractions, all ad hoc.
so what was it like? The light did not.
Definitely it isn't, right?
The
It's
light
not
did
ad
not.
hoc.
Lorenz contractions, all ad hoc.
So what was it like? The light did not.
Definitely it isn't, right?
The
It's
light
not
did
ad
not.
hoc.
that's just yes.
The light did not. It is ad hoc. The light did not
No, it's not.
interfere as was expected, right? So, but it did have an interference. Like the light did not get to the receiver at the same time. And according to relativity, the light should get to the receiver at the exact same time, right? According
What
to
about all the
relativity,
tests? What about all the tests they've rigged sneakily to make it match though with the basements and all that?
yeah, since then they've
Can
tried
I?
to get it closer and closer to zero because what relativity would predict is that even though if you account for the Earth's orbit, one of the light beams should have had to travel further, thus take longer, thus be further behind, right? That since you're on the Earth, you're not able to detect that motion. So both of the light beams should have been split, gone perpendicular, come back and recombined, and then got to the receiver all at the exact same time. Because light is constant, we're in the Earth's reference frame, therefore there would be no detectable interference, right? But there was an interference pattern. So what they did was, but it was way smaller than what was expected if it was based on Earth's orbit. It was 1/6 the value. So what they said was, oh well, that little bit of interference that is there, that must just be instrumental error. Like that isn't actually there. That's because it can't be according to relativity. Okay, so they had to propose an explanation as to why the Earth's orbit wasn't detected. And so they came up with relativity, which says, well, basically the distance, although if you zoomed out of the Earth and you looked at you accounted for the Earth's orbit, the distance of one of the light beams would have been greater. Therefore, it would have taken it longer to travel that distance, right? Like if you had Usain Bolt run 100 yards or 150 yards, it's going to take him longer to run 150 yards at top speed, right? They're saying, oh, well, although that should have happened, the distance for the light beam that would have had to travel further because of Earth's orbit, that distance actually contracted. And it contracted and then stopped right where it needed to be identical to the other light beam's distance. So it contracted just the perfect amount conveniently. And to phrase it the way
Not
Einstein did,
conveniently.
oh, it's convenient. All right. And to phrase
No,
it the
it's
way
not.
that, oh, it's
It
very
wasn't.
convenient.
No, you were lying when you were saying that they came up with special relativity because of that.
No, Witsit was having a good run of like you guys don't need to interrupt him. Just
Yeah,
let us
so
Yeah,
finish.
that's one
because
thing.
he's piling on lies now, and it's becoming very obtuse to talk about
I
this when you're
wasn't paying
piling up so
attention.
many
Hold
things
on.
that
I
are
wasn't paying
incorrect.
attention. Was Witsit interrupted?
Yeah, of course.
Yeah.
I
Yeah,
mean,
he
that's what.
would.
Yes, you
Of
are.
course. Just let him finish,
Hold
guys.
on.
Come
Are
on.
we talking about the Michelson Morrison
No,
experiment here?
guys,
Is
please
that
just let Witsit finish, please. And then you guys can have questions, comments, concerns after.
Einstein himself said that when he came across the results of Michelson-Morley, that's what led him on the path to special relativity. Like Einstein himself said, that's what started him down the path to come up with special relativity. So anyway, so what it basically says is that that distance contracted, and to quote Einstein, which he says this in Special and General Theory of Relativity, where he kind of gives a summary of both theories. He calls it like the paper for your grandmother or something. It's supposed to be the simplest version of it, of the two theories. And a summary of it, he says that it contracted just the sufficient amount needed, right? So it makes, even though one distance would have been greater if you account for Earth's orbit, it contracted for the observer on the Earth's reference frame. So the perfect amount to make it look like the distances were the same. And simultaneously, time slowed down because it would have to, right? Like if Usain Bolt ran 100 yards, 150 yards, it would take him longer to run 150 yards if he ran the same speed for both races. So then if you were to say, well, that 150 turned into 100, right? Then you would have to also say that time was slowing down at the same time the distance got shorter, so that that he would get done with both races at the same time. Okay. So that's what they claimed happened, that time slowed down and that the distance shortened for one of the light beams, and it made it look as though the light beams got to the receiver at the same time and there was no orbital motion to be detected. Again, they actually didn't get there at the same time. There actually was a separation, but they claim, oh well, we'll just ignore that because it's close enough, and it must just be because there's something wrong with the instrument because there was no explanation for it. Okay, so this is what birthed this idea. It's needed to explain Michelson-Morley, and subsequent replications of the test. Dayton Miller had much more precise versions of it, and this is why Einstein said, if Dayton Miller's results are correct and it is not, his readings are not due to some fundamental instrumental error of which I cannot explain, then my entire theory collapses like a house of cards. Okay, so that's the full context of what's going on. That's completely unfalsifiable. If you tell me, if I have a 12-inch ruler, and then I'll land the plane here. This is what started the whole thing. If we have a 12-inch ruler, and then you tell me that it actually just got shorter, But if I go look at it, it's going to still measure to be exactly 12 inches. And you say, yeah, it looks that way, but that's an illusion, right? It actually was longer and got shorter. You just can't tell. It's going to still look like it didn't change. Trust me, bro. I'm like, okay, that sounds like magic. That's a cool story, man. Like, prove it. You know what I'm saying? So, I mean, that's literally a still man and an accurate representation of what happened with Mickelson Morley, bro.
I've read it now, and I think you're still slightly misinterpreting it. You're saying the issue is the interference pattern showing up, right? Equal distance, no relative motion. You should have perfect overlap, no interference. Basically, right?
No, well, technically, you should have had quite a bit of overlap and detect the orbit.
Yeah, but so you're saying it showed it wasn't in the same exact phase coming back, right? You're saying that's what the
Yeah. Yeah, I'm saying
experiment showed.
if we assume relativity is true and time slowed down and the distances got shorter, then they should have been perfectly in phase. I'm not
That's
assuming that though, because
incorrect.
that's insane. No, that's not incorrect.
No, no, because the only way that would happen to begin with is if they turned both the lasers on at the exact same time, which you cannot do physically. And
Okay.
if you're saying they slowly adjusted them to match the phase, that's not really
You missed.
seeing it they
You
matched.
weren't listening. You
No,
weren't
no, hold on.
listening. I
Wait, wait,
addressed that
no,
part.
no,
You weren't
just real quick.
listening. There were no
I
late.
was
I'm
listening.
going to give it back to you. There were no late. You weren't listening. There were no lasers invented at this time. It was a light beam. They shot one light beam and they used a beam splitter, and it split that single light beam into two light beams, ensuring they were perfectly in phase. Because, like you said, there was no way to ensure you could shoot them at the exact same time. So what they did was shot one light beam and split it in two, and you can of course ensure you shot the one light beam at the same time, right? So they were perfectly in phase. So go ahead.
Yeah, I mean, you can basically represent the same thing with lasers. Yeah, but I get it. It was a light beam that they split. So you're saying they start out at the same phase separation when you split the beam. Depending on, I mean, if you don't have lasers, how many beams are actually in that to be split? You'd expect it to have quite a bit of overlap, right? But the
No, no,
problem is
no,
that
no,
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 hold on.
not right,
Listen,
not
this is
right.
the one thing I've been trying to finish 3 times. Like the thing you should
Well, you just
expect.
made that up.
What no, what Michelson Morrison should have disproved to disprove relativity is what you would expect to see is the phase continually shifting and not being stuck in either interference or matching phases. The fact that the one beam isn't constantly scrolling along at some rate, that is the problem. So that is why it doesn't disprove
Incorrect.
relativity. No,
Okay,
that is
you're
entirely correct.
you
I read it.
you just made this. Okay, cite where when you use the beam splitter that there actually is a separation and that the light beams are not in phase. You just made that up. You
Yeah, the
objectively
phase
just
doesn't
made it up.
increase. The phase difference is fixed, right? Like even if it's not that they're measuring like these wet light waves moving past one another. They're maintaining what's happening is they're measuring the distance between equal points on each phase, and that gap, that phase difference, so to speak, that spacing is what's being measured, and that's a constant.
Yeah, there's no progression.
It was always explained to me like if you
Yeah,
shine a flashlight standing still on the ground, the light will travel at the speed of light. But if you're in a really fast car and you shine the same flashlight at the same exact times that someone shines it at the same spot on the ground, you would think that the light would travel at the speed of light plus the speed of the car that it's also moving. But it always travels at the same speed, whether you're standing still or moving forward when you turn the flashlight on. So it was
That's not
explained
true.
that time has to shift in order to make that light always travel at the speed of light.
That's how it was explained. But you can't. Just to be clear, you are not going to measure the difference between a car with the flashlight in it and the flashlight by itself
Well,
because the percentage difference is so tiny, like it's like
I,
imperceptible to you.
I know
We measure with
that. You don't
GPS
have to
though.
physically use a car. I just said that as an example.
But that you're right.
What?
That is the way they try to explain it. Yes.
Yeah, you're right about that.
But that's what we're talking about, right? Like So they split the beam, it's perfectly in phase. Then they go perpendicular to each other, get reflected off of mirrors, come back to the middle and meet each other, and then they go to the receiver together. If relativity were true and time slowed down and the distances contracted just the perfect, precise amount to make it look as though the Earth were not moving, which is the official claim, then the beam should have reached the receiver at the exact same time. There should have been no interference. That right there is actually granting an ridiculous claim that the time slowed down and that the distance contracted, but it just looks like it didn't, right? Like that's ridiculous on its face. But it's even worse than that because even if you temporarily grant them that possibility, that would mean that the light should have got to the receiver at the exact same time, and it didn't, right? There was still a fringe shift. And what they said, the official explanation for the fringe shift is must have just been an instrumental error that we haven't figured out yet. So, nuh-uh, it's not really there. Like
You're
literally.
saying you're saying they split the light and one beam had to travel further than the other, and it still got there at the same time? I thought in an experiment like that, one would get there before the other.
According to the idea that the Earth is moving around the sun, right? Like,
Okay, I got you.
yeah,
I see. I forgot that. I left that part out.
yeah. Like,
Talk.
imagine if the Earth was moving. We're going to use crude terms just to create the idea, right? Like, say the Earth is moving east, and then one of the light beams moves east, and then the other light beam moves south, and then they come back and recombine, and then both go west, right? The light beam that went south was moving against the motion of the Earth, right? The Earth was moving out from underneath it the other direction. It was moving east while it was moving south, but the
Right.
other light beam was moving east with the Earth. So then there's going to be a difference in distance relative to the Earth, right? And they're going to come back. So one light beam is going to have to travel a greater distance, which means it's going to take a little bit longer for that light beam to get to the receiver. So once they recombine and then get to the receiver, one should have been slightly behind the other. And what that does is make them start to overlap, right? Because they're not in phase anymore. It's waving, they're both waving, but one's behind the other. So they start intersecting. And this is called an interference pattern. And you can measure the distance between these overlaps, right, to get a fringe shift, like how much one is shifted from the other. Right. So according to relativity, to try to fix the problem, they claimed there would be no shift because even though the Earth is moving, right, like technically underneath the light beam, like moving in the other direction from the light beam, when you're in the Earth, you're in the Earth's reference frame, and within that reference frame, you can't detect that motion of the Earth's orbit, right? And that time is slowing down and distances are contracting within that reference frame to make it look like the Earth isn't moving, even though it is. So, like a stillman of relativity is that when you're on the Earth, everything will look identical, exactly the same if the Earth were stationary, right? Like that's what relativity says. The issue
Yeah,
is that it did detect some motion though, bro. Like there was a fringe shift. And then Dayton Miller did it over and over and over and over because they were basically saying, well, that fringe shift must be just an error. And they said it must be the temperature of the device and the ambient, environment is causing the device to expand. So then Dayton Miller like introduced radiant heat sources to the device to show that that isn't true, right? That didn't cause a major shift at all. And so he did everything that they threw at him. He tested every possible variable to see if the instrument itself was messing up. So then we have to be like, wait, what? So what motion is it detecting then? We know it's not detecting Earth's orbit. And according to relativity, it should be detecting no motion, but it is detecting motion. So, like, wait, what motion would it be detecting? And then when you fast forward and you look at Michelson, Gell, Pearson, which is where we basically use the same principle of interferometry, and we try to detect the sidereal rotation, so the rate that the sky spins roughly every 24 hours, right? The predicted fringe shift for that, using the same type of equation that we use to predict the fringe shift for orbit, it actually did match, right? Like the separation of the light beams actually did match what it was supposed to based on the rate that we see the sky spin. So when we combine these two pieces of evidence, there's only one logical, viable explanation, and that's that the Earth isn't what's moving, the sky is what's moving, and that's what's being detected with the interference patterns. That's the reason one light beams behind the other. And the analogy is like if you jump into a stream of water that's running, like it's a stream with a current. You jump in it, you're going to be able to swim a little faster if you swim with the current. But if you try to swim across the stream, again, like perpendicular to the current, then there's gonna be a drift that's pushing against you. That's gonna slow you down. And so if the sky is spinning within an ether, then the light beam's gonna have to go through that. There's gonna be a drag, a drift, and that's gonna cause one light beam to slow down a little bit and be behind the other. And that's what we see.
Is that what they call frame dragging? Or is that what frame dragging is? Or is that something totally different?
Yeah, it's different. Frame dragging within relativity is a bit different. Frame dragging is where Einstein wanted to have his cake and eat it too. Yeah, but it is similar principle. Yes.
Cool. I like that
Yeah.
explanation. Witsit.
Yeah, bro. So then, just to give you guys like the full still man of your side. So what they say then is it was just the instrumental error. This is where Einstein says if Dayton Miller's results are correct and there isn't some like instrumental error, then my whole theory collapses like a house of cards, etc. They just continue to assume there must be some error, right? Dayton Miller's results were largely just kind of swept under the rug 'cause they didn't know what that instrumental error was, so they didn't have like an explanation. And everything they threw at him, he debunked it. So what they would say now, like if you went to Wikipedia, they would say, well, over time, the interferometry got more and more and more precise, and the results have gotten closer and closer and closer to zero, because what it actually is zero, right? Like we discussed earlier, they should have got to the receiver at the exact same time. There should be no separation. And that sounds good. I guess you could think that sounds plausible, right? But when we actually looked into those tests, what we found out was they are like cooking the books. The tests are like changing the length of the arms, or they're running one of the light beams through a crystal to slow it down, and they're going down underneath basements, because Dayton Miller's test showed that the closer you get to the sky, the more motion you detect. So they were like, okay, we're going to go underground then, and we're going to run the light beam through a crystal to slow this one down to try to get it to even out and be zero. It's like all these weirdo tests that are totally, bad faith and cooking the book. So there are tests that have been done not doing stuff like that. Like using radio waves, for example, in modern times, that have confirmed that fringe shift is still there. It is still a real thing. So that we can detect the motion of the sky. We just can't detect the motion of the Earth.
They also put it under vacuum too, because that reduces the amplitude of any signals, any time-dependent signals in space.
I was reading a pretty good book, and this guy, he's like a famous physicist. Maybe you guys have heard it. His name is Wolfgang Smith. I know. Baboon has heard of him, and he has a chapter in vertical causation called the argument. What is it, against design? Anyhow, the point is that he's a notable source, and he cites all the things that like Jesus here and Witsit cite, typically being like Wang and the Lorentz, reaching towards that. And this guy is a pretty notable physicist, and he takes your guy's position and exact argument like to the T. It's really and it's a good book. I just figured I'd mention it.
Nice. Yeah, I gotta step away for a sec.
Who is that guy that was arguing with you about Michelson Morley in here a second ago?
I don't know, but he admittedly wasn't familiar with it, and then stepped away for a couple seconds and said that he had just read it, quote unquote, and realized I was wrong. And then he said that the reason there was a fringe shift is they shot 2 lasers and they weren't shot. You can't make them shoot at the perfectly same time. That's why there was a separation. Blah blah blah. So,
Oh yeah, that's
he left.
that's what made me think of it, because the Wolfgang's, typically you hear people say, no, the Michelson Morley is an argument against the ether, right? Like, oh, it disproved the ether. So this renowned physicist, Wolfgang Smith, he claims that the Michelson Morley is a direct proof of a stationary Earth. Then he goes to Mach's principle and all the and whatnot to show that there's a movement correlative. It's really kind of I never heard somebody in such a position put it out there the way he did. Yeah, he doesn't even pretend that, oh no, this was just a disproving of the ether or medium of which light propagates. It's just a direct refutation against the 30 kilometers per motion of the Earth. Like, that's it. So it might be useful to bring him up. The reason I'm kind of bringing it up, it might be useful to bring him up as a citation against the against the Globers, who are always saying, well, listen, if it was true, a scientist would have seen it. They would have called it out. There are scientists, and we know the other few, but this guy is top tier. I know that Christ is King. I know that you often bring up the guy Wang who did the the light on a conveyor belt, and he brings that up. So
Yeah, so anybody who hasn't seen it and they actually want to legitimately spend 30 minutes to an hour studying this and learning it properly, you can learn it in, about that amount of time. There's a channel called Ask Us Whatever on YouTube, and their 2 most recent videos, Ask Us Whatever, are about the Sagnac effect and about how light speed is not constant in vacuum, and about how you can demonstrate this. And so I'll put both links in the chat right now, but it's a very good it's like a very good explanation for everybody to understand all this stuff, like the meta kind of from our side. Now this guy, I don't agree with everything he believes, because I think he's a Glober and he believes in space and stuff, but nonetheless he believes in ether and relativity's wrong. So he does a good job of explaining that.
yeah, the disappointing part is, like, relativity is wrong, right? Like, as if it needs to be disproven is just like fallacious. Right? Like, somebody needs to disprove relativity. It's never been proven.
Yeah.
You're so right about that, no tanks.
Yeah, it's a shame that it always seems to be like it always seems to be the case. So we have to argue against it.
Why falsify something that's never been verified? That the premises have never been verified to be true.